Before starting my talk, I'll just first thank the organizer for giving me an opportunity to talk to you regarding something for this DRDO's planning. My special thanks to Dr. Satish Reddy, who has inspired me to talk how the DRDO and academia interactions we have been planning in DRDO. Yes, as given introduction by the chairman, so I now thanks chairman and co-chairman for giving me this opportunity. Okay. As briefed, I am basically have been working in electronics for quite more than 30 years, and I have very little knowledge in electronics, so it would have been more convenient for me to talk something of electronics or communications. But today, I thought I will deviate from my special topics, because the Indian Science Congress is a forum where multidisciplinary people attend. So instead of going to the specific domain of electronics, I thought I will talk how DRDO is planning for this technology management in headquarters, how DRDO is having a collaboration with academia, what is the DRDO's plan. Because if you see in many forums, our Honorable Prime Ministers and Government of India is telling, let us harness the manpower resources what we have in our country. We are having the third largest scientific manpower in the world, and we are having sixth largest scientific papers in this world. So let us try how to best utilize those expertise in the country. Before going how do we utilize the resources in the country, as a chief controller of technology management, I will just give a little background. What is basically a technology management and how do we define a technology roadmap? These introductions are essential to the extent that since the participants are mostly faculties or the researchers, where the involvement of the faculties or the researchers can be planned and programmed, what is our thought process, we are just want to inform this August gatherings. Yeah, basically if you see that in the technology management, what we do is we create a sort of process to manage the technology fundamentals such that DRDO can have a competitive technology advantage, whether it is a technology strategy, whether it is a technology forecasting, or whether it is a technology scouting or technology roadmap. So these are the job of a technology management. How do you do that? This, if you see, our main drivers are our armed forces. As our previous DGL is told that she is working for this life science, so she is getting requirement from the armed forces. Our drivers are armed forces. They have their requirement plans for this next services, weapons, platforms, missiles, also they have projected the requirement. Based on the requirement projections, we perceive the technology gaps. What are the technology gaps? Means what competencies we are having. Are we in a position to match the requirements of the country? Are we in a position to match the technology speed of the world? We try to perceive what are the technology gaps. First, we perceive the technology gaps. At the same time, when you see across our country, we have many innovative ideas from our bright youngsters. Can we tap those innovations? Can we fit those innovations into our technology roadmap? Is it possible? How to do that? This is what we call as a technology management in general. Then there are certain technology requirements from the different perspective. How to translate those operational requirements into technology blocks or modules. That is the job of the technology modules or technology management. Before coming to that, what is the strategy we are going to follow in our DRDO as a CCTM? So I just take a 2-3 minutes in these slides, because this strategy is nothing that this an organization mix between the internal resources and skills and the opportunities and risks that are available in the external environment. What is done is, our department or our organization has a very strong core competencies in many areas. If we see, we have proven our capability in terms of missiles, strategic systems, platforms, weapons, aeronautics. This is our main strength. So having kept in our mind the core strength, can we go ahead with the core strength? Can the core strength become a routines for our development? Or can the core strength become a rigidity of our system? How to do that? So, core competencies should not be a rigidity. How to harness that? Because the students, the industry, the academia, they are having a different capabilities. So, is it possible to complement those capabilities with our core strength? How to use? So, this process or this strategy we are following to manage the technology and how we are managing, that is my basic topics. If we see the development of a technology, how does it happen? Basically, technology is nothing but what is happening in the institutes, academia. First, we have a no knowledge of a system. Suppose a new requirement comes, we have no knowledge. So, first we have to create from a no knowledge to a new knowledge. How to create a new knowledge? That is the job of the academia. So, new knowledge to the theory building. If a new knowledge has been generated, suppose an application has been generated, how to build a theory? Again, this academia, researchers, youngsters like you comes. So, new knowledge to theory building, then theory building to principles of applications. How to make the principles, how to make a systems, how to make the theory in terms of our real life, how to translate the theory into real life. Who will do that? How to do that? This is all job heading. So, similarly, there are 10 steps involved and ending with a product and how to optimize the product. If you see the conventional technology development methodology, why I am projecting this slides is a different. This may be interesting to the students. If you see the technology development cycle, this is a life cycle, how a technology grows. This we typically call it as an S curve. It has basically 4 stages. First stage is the emergence, which is called a bleeding stage, where the technology grows. Where from we get? Bleeding stage means suppose we need an aircraft, we need a missiles. What are the requirements? What are the research going on? So, bleeding stage, the researcher gives us idea. These are the bleeding stage. We get the generated ideas. We get the bleeding stage. Then after that, what is called the leading stage? How to take the leading stage? In the leading stage, the complete academia, industry, DRDO comes into picture. Where there is a fast growth of technology, the leading stage comes. The leading stage has a very short duration. After that, we get into the maturity stage. By the time we mature the technology, its technology is available for use, we take help of the industries. How to get the industries into our system, that is one of the job of our technology management. If you see, if we cannot cope up with the present growths, we are not likely to succeed alone in a single in-house DRDO as a independent standalone systems. After the maturity stage, if you see there is a decline stage in the S curve, means it can also cross back to zero. Decline stage means the technology becomes obsolete. The technology was developed, the technology has become obsolete. How to do? How to cope with the technology? So, how to plan it? The breeding stage, the leading stage. When to start the next phase of technology? Suppose, for example, if we talk of 8085 microprocessor, which started in the early 60s, 70s, is it workable today? Can we manage? Of course, we can, but there are some more improvements have occurred. So, before this technology goes to an obsolescence stage, we have to take the second technology. What are the trends? How it goes forward? How it to be carried? So, if you see the S curve, I have taken first technology. Before the first technology goes to the maturity stage, we start with the second technology. Who will help us? As I have been telling, in each bleeding stage or in each leading stage, the involvement of the academia and the students we are planning. I will come into more details. I will take a specific case studies, what we have been planning with different academia, and we will explain even more elaborately what are the stakeholdings, how do we go ahead further. So, since I have taken this, suppose 8085 become obsolete to the 386, 486, 586 short nodes, days are coming, they are not sitting. Means each day's technology changes. Our main target is to address the technology obsolescence before it comes to total things. In this, what basically follow in the DRDO, we have worked out a capability maturity level. In this capability maturity level, what we plan is this from the ad hoc practices of conventionally going in the technology development, we are now going to a structured process. In this structured process means where to involve students, how to involve students, how to get it done. All those are being structured. That we are calling as a capability model or capability maturity model for technology development. This is on side. What strategy we should follow? This is a 6-dimensional slides. In these slides we have given, in each axis I have plotted 2 parameters. If you see the x-axis, there is a technology knowledge which says whether this technology is established or it is an emerging. In another axis, we have a different directions in terms of business applications or application to the user. Has it a high potential of application or it is a low potential of application? Whereas in the x-axis, we have only in-house level of knowledge. This graph shows what research we should take. We try to fit in this graph. Means, if our in-house level of knowledge is very low and the business application is very low, means doesn't have enough users, we prefer let us go ahead for standalone systems available in the market and buy it. On the contrary, if we have a very high in-house level of knowledge, means we are mostly come to the mature technology, and also there is a potential applications in different spheres, whether it is army, navy or air force and whether it is, or even civil society, we take a development model. In between, if the knowledge is established or whether it is an emerging, if it is to be done through a research mode, if it is a totally emerging field and our in-house level knowledge is very low, we involve the researchers. So, these are the one of the models how the researchers, how the industry. We have one more also options here, optimize and or outsource. Means if the in-house level of knowledge is very high and also the technology is established, let DRDO or researchers not work, let us go to the industry. So, this is how the maturity, capability maturity model works in terms of technology management or in terms of development management of the overall systems. Why I am telling all these things is, this process once it is structured, where and how to involve the industry, how to, whether it is to be developed, whether it is to be purchased. Now, this is one of the technology evolution models. The time is there? I am just giving a technology evaluation model. If you see, this technology evolution model has a basically 5 levels. In the 5 levels of capability maturity, if you go through this thing, I have projected in the 5 levels. The first level is the scientist decisions. Scientist decision means what? Scientist in general here, not they are the DRDO scientist or CSR scientist. Scientist means who are doing the research work, including academics. So, what is scientist does? Scientist does the literature study, make a proposal, make an hypothesis and prepare a document and goes for a research. He may go for a publications, he may go for a patenting, he may go for anything. In this model, in our capability maturity, we are calling it as a chaotic model. Why it is a chaotic model? Because in this process, the dynamic is changing very fast and the complete process is advocacy, because we are not sure whether this technology is going to mature or not. We are also not sure whether it leads to any solution or not, because by the time the researcher comes, some concept comes, some hypothesis comes, it has to be bring into a system. It has to, whether it is realizable, whether it is a workable solution, whether it is non-workable, we have to go into that. So, this is called a chaotic, first initial phase, we call it a chaotic phase of this, our technology development, in technology development terms. Once this chaotic comes, if you see an S&T loop also, I will just put my cursor, if you see this S&T loop, in this S&T loop, what is that? The hypothesis is made into theory building. So, in this S&T loop, we prove whatever researchers has done, it's realizable, it's workable under the given environment, under the given platforms, under the given circumstances also. Based on this, we go to our next level, which we call as a S&T proposal or S&T project decision basically. What is that? In this, the hypothesis is proved and this proof of concept are being taken. Once this proof of concept are taken, we say that this process is repeatable, this process is realizable, and we have some consistent result out of this research outcomes. In this process, normally being done by some of our laboratories in collaborations with the academia. So this is the level 2, what we call a repeatable levels. In this level 3, this is a totally structure defined. In this level, if you see, we have got a prototype, we have do the design validations, we have already worked out our technical risk, our investment risk, everything. Based on these risk factors, we see whether the design can be documented appropriately or not, and the standard procedures can be established. If any infrastructures, any facilities, any needs to be created, we work out here in this process during the prototype validations. Further to that, this we call as a managed process, where management can identify to adjust and adopt the process particular to the projects. This is a project specific. If suppose a high infrastructure needs to be developed for this, the management takes a decision, the government takes a decision, and based on this process capability, once it is established, we go for the final optimized model, where the industry involvement is there, which we call it as an engineer's decisions. So in this, we have a 5 level of decision: scientist decisions, S&T loop, S&T project decisions, engineer's decisions. Finally, the velocity of research is determined in this process. This is what we call it as a technology evolution model. Okay, this is only my thought process, so this may not be taken, this presentation, technology development strategy. This is a strategy what we are telling, typically not to scale, and it is just an idea. So I have taken a 30 years total technology evolution model, which can be dynamically updated. What I want to convey by this is, if this science-based projects, this is the science-based project. The science-based projects we are taking, we involve the academics or the universities, including the research scholars, including faculties. Typically, what I am trying to tell here, we are planning to spend a 5% of our budget in this university academia interfaces. But typically, what previous or experience says, if the concept is not existing, and if this scientist brain has to be converted into a mature technology, typical lifespan is 25 to 30 years before it comes to a technology. This is our previous experience. Our objective is how to make a strong India, how to build our own independence technology to reduce the time span from 30 years to 10 years or 15 years. This is based on our present experience. When we go for this technology maturation, once this technology is matured, then we involve some industries, universities, SMEs, R&D establishment. Our target is, let us plan a 10% budget of our total technology development systems, and we involve all the stakeholding partnerships in these projects and programs. Once it is matured, then we say we have got a product. These presentations, I marked, if you see, or if you mark it carefully, even a mature product is there, we take 5 years to come into a product, actually usable product. If you see 0 to 5 years, it is a countdown time. So in 5 years, we can make it a matured. However, from the basic theory, the concept to the theory takes 30 years. In between the industry, what it takes, in between the universities, R&D, what it takes. In this, what we are trying to go is, we are planning to go in a very focused approach. This strategy is to going for a very focused approach. And I have been telling in many IITs right now, because of the technology, in my capacity as technology management, that it is always a good approach to have a technology strategy. How long time frame, how short time frame we are going to take. If these models can be reduced further, can we, to a specific technology, this is only generic things. For a specific each technology, we are working this model, how long it takes, where we will go, how fast we can go. This is just a model I am highlighting. Then, we have brought a new concept in our DRDO called coherent directed research. what it calls coherent directed research. Uh, as a researchers, you may be aware of this general research is subject-wise and other things. The basic objective of the directed research is we begin with a goal and objective for certain topics. We should have a very specific goal, what we want to do have a research, what should be our objective, what are the areas, how it should be focused. So that is the objective of the directed research. How the project will be selected, how it will be prioritized. These all criteria are decided by our national needs, by our armed forces needs, by our country needs. So we prioritize the projects. This new concept we have created only last few months, and we have established some process in this direction. So I am just coming into this as a specific example for this. So we prioritize the subjects, we prioritize the topic, we see the future size of the market, what is the requirement, what technology we need to adopt. So this is calling as a directed research. Why this is focused approach? If you see that if you go through the history of the development of technology, for example, even if you go for even our fiber optic systems development, there are two companies called this Corning Glass and Nortel Networks, which were working earlier in 1990s. And when the initial fiber optic cables were being developed, the company grew leaps and bounds, and in a few months' time they were in from few dollar to few $1 million and $1 billion. But when the crash came in 2000, both of them collapses. So say from a $100 billion company, they are converted to a $1 billion company because they thought the market is going in these directions, but let us focus in different directions and diversify the technologies. In this process, what happens? The one company called Nortel completely closed down. However, the other companies succeed because they worked out their specific map. What is the focused area? How the fiber optics is going? Because if you are working today in on materials for the fiber, is it going to sustain for a long time? Is that technology be available for a longer duration? How to do that? So that's how the system works, and some of the succeed, some of us fail. So we have taken this approach. We call it a directed research. We go through our perspective plans. Perspective plans means what is DRDO's requirement, what is national requirement, what is Army's requirement. We do a system analysis. We have a group called system analysis and modeling group. We get the system analysis done. Is the platform, is the system, is the missiles, is the what we are looking for, is it realizable? What will be the deployment scenario? What is the war game scenario? Everything we simulate. After this is done through the system analysis, we see the critical technology and maturity estimations that we do ourselves. I will come into something. The time is there? Time is not. So this critical technology and maturity estimation, based on this critical technologies, we find out a research roadmap. Then I just explain because some of the if there are some professors there, I will just explain. So I am just explaining this slide. The simple reason is the faculty send us a proposal. What is the difference between the directed research and the normal project proposal? I will just explain. In the normal project proposals, when DRDO gets project idea from any faculties, we try to fund it. But normally these project proposals are not interlinked to each other. They are not correlated. They are not directed to a specific deliverables or goal. In a directed research, what I have shown in this transparency is, if we have a specific programs P1 and P2 or P3, each program is divided into certain technology modules. Each technology modules, we identify what are the modules we are having. Suppose I will take a specific example, another 2 minutes. What are the modules we are having a strength? What are the modules we are lagging? Those modules only we plan for a project proposals. And under those modules, we launch the projects and programs. Objective is, all the projects under the directed research are interlinked. There is a way forward for each project proposals. There is a link to our DRDO program, and there is an end target of a system, devices, platforms or missiles or something like that. Something end target is there in our mind. So that is the difference between the normal research and directed research. In the DRDO, we have various mechanism to fund it. One we call it the Directorate of Extramural Research. In the Directorate of Extramural Research, what I was telling, we initiate the proposals, we get it done and do it. We have 4 research boards, Aeronautics R&D Research Board. The Aeronautics Research, the Directorate of Extramural Research takes project anything between, or we call it a technology readiness level from 0 to anything up to 4, we take it. If we call of a research boards, 4 research boards like Aeronautical Research Board, Armament Research Board, Naval Research Board, Life Science Research Board, these research boards proposals are mostly top down, means what DRDO needs, we try to do that. Even if some proposal comes, that also we take it, provided it is linked to that particular specific projects or programs. We have also an industry interface, we call it a technology development fund. Recently, our government has supported this fund because to make our Make in India more stronger. So this we call it as a technology development fund, where specifically the micro, small and medium industries can be funded to do any research work. This scheme is already operational and it is available in our DRDO website. The proposals has been given. Any other proposals are also will come from any industry, provided it meets the DRDO's projects, programs and aligned towards our requirement. That is the only constraint we are having. I'll just take on for 2-3 minutes. We have created some centers of excellence. I'll just tell all those centers. We have, in this directed research mode, we have created 7 centers of excellence as on date. The first center of excellence was Center of Propulsion Technology, which has been created at IIT Madras and IIT Bombay. This centers deals with a targeted deliverables of aeronautical systems in terms of engine development. So 4 technology verticals we have identified for that, including the gas turbine propulsion, hypersonic propulsion, solid liquid propellant modeling and morphing technologies. We have one more center created at Kolkata called Jagadish Chandra Bose Center of Advanced Technology. As you might have observed in yesterday's our Honorable Prime Minister's talks, he was talking of the future technologies related to India in terms of cyberspace, in terms of robotics, in terms of platforms. So to target some of these in terms of robotics, in terms of cognitive systems, we have developed this center in directed energy weapons. We have set up one more center at IIT Delhi called Joint Advanced Technology Center. This is basically for advanced ballistic, special structures, electromagnetic devices, terahertz, smart and intelligent textiles, brain-computer interface to enable the specific our future robotics technologies, robotics warfare, robotics systems, humanoid, exoskeletons, all these things we are targeting in these systems. Advanced Center of High Energy Materials in University of Hyderabad we are already having. We have a DRDO based Center of Life Science in Coimbatore. We have a Research and Innovation Center at IIT Madras. I do not have much time to talk. I just only one example I will take. Suppose I am taking example of small turbofan engine. What we do is, this is a part of Center of Propulsion Technology. In the small turbofan engine, if we take as a specific example, this is my last presentation, I will not go for that. In the small turbofan development engine, if we say, we have various technologies domain, like aerothermodynamics, ducts, fans, compressors, turbines, combustor, fuel, structures, rotordynamics. Out of all these things, if we see, we have identified what are the areas we are lagging, research projects. Our gaps was understanding of flow physics and loss mechanisms in small engine. We have launched project in this directions, many projects, loss reduction in ducts. Anyway, this is only a concept, I will not go because I have only 14 finished, I have 45 more, I will not go into that more details. Thanks very much. If you have any questions in terms of technology, trialing of DRDO, of anything or anything what I told or anything you want to know, please say.